In this video, you will learn about simplifying, multiplying, and dividing radical expressions. First, let's review some of the terminology associated with radicals. Perfect squares are numbers whose square roots are integers. And the examples are given below. They are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. A radical expression is defined as an expression that contains a radical. And examples of this are either something like 2 square root of 3 and square root of x plus 3 because they both have that radical. Now the radicand is the quantity or expression under the radical sign. And you can simplify a radicand by removing perfect square factors from the radicand. Now, in order to simplify a radical, you must first find the largest perfect square that is a factor of the radicand. Then you're going to rewrite the radical as a product of the perfect square and its matching factor, and finally simplify. Our first example asks us to simplify the square root of 50. Now, the largest perfect square that divides into 50 evenly is 25. So I can rewrite this as the square root of 25 times 2, and I can even split up the radical so it would become the square root of 25 times the square root of 2. If I simplify the square root of 25, it becomes 5 square root of 2. And that would be your final answer. Now, if we want to simplify the square root of 192, the largest perfect square that divides into 192 is 64. So I can rewrite it as the product of 64 times 3. Separate the radical, so it's the square root of 64 times the square root of 3, and the square root of 64 is 8. So your final answer is 8 square root 3. In our next example, we have negative 5 square root of 300. So we now have to deal with something where there's a coefficient outside. However, simplifying the radical is the exact same. If I were to find the largest perfect square that divides into 300, it will be 100. So it would become negative 5 square root of 100 times 3. I can split up the radical, so it's negative 5 square root of 100 square root of 3. The square root of 100 is 10, so it becomes negative 5 times 10 square root of 3. And if I do that last part of multiplying the negative 5 times 10, it becomes negative 50 square root of 3, which is your final answer. Now, traditionally we want to take out the largest perfect square, which is what we're going to do in method 1. If I were to simplify the square root of 200, the largest perfect square that would divide would be 100. So I could rewrite it as 100 times 2, split it up so it's the square root of 100 times the square root of 2, and the square root of 100 would become 10. So it's 10 square root 2. Now some of you may say, well, I could divide a smaller perfect square first. So for example, with the square root of 200, you may say, oh, 200 can be divided by, for example, 25. So if I were to do that, it will become 25 times 8. So it's the square root of 25 times the square root of 8. And if I simplify, the square root of 25 becomes 5 square root of 8. The issue here is that this is not fully simplified. I can continue to simplify that square root of 8. I can make it so it's now 8 could become 5 square root of 4 times 2 split up the 4 and the 2, so it's 5 square root of 4 square root of 2, and the square root of 4 becomes 2. So it's 5 times 2 square root of 2, and your final answer is 10 square root of 2. Now, this gets you the right answer, however, it requires a lot more steps. And that's why we recommend that you take out the largest perfect square. However, if you don't, know that you need to continue to check to see if there's more perfect squares you could take out.